one. Okay. So this one AI interaction here, one of the thing is that there's a different type of mode people using. Okay. However, the field is still I would say it's not mature enough to define its own what's the best way to interact. So oftentimes you will see they are kind of adopting from other interaction that well known. Okay. Because one of the things that make AI new is the ability, no, the requirement to have to deal with reality, to do the reality in which is augmented on. Okay, that was the concept there. There's an interaction for type. Okay, so I'll talk about that one by one. Okay. The first one here is data annotation. So this one is relatively straightforward. So you have 3D virtual or 2D even objects that register in a space. When we say register, they exist inside 3D space. They're not just imposed on it. So remember, AR are different than you just putting the image there like a Photoshop. Okay, because AR need to be able to move the viewpoint. Okay, so you have to be able to move your head around, looking at them, just like looking at Euphoria. Your pattern move, your target image move. So therefore, your annotation or your 3D character 3D object need to change location accordingly. So the update of this is done every frame. So that's what create the illusion of having a 3D object inside a 3D world. So this one is simply putting content layer on top of the image on the right here from UNC, so early work in AR, okay, University of North Carolina, um, Chapel Hill. Yep. So what they do here is in the ultrasonic groups, X-ray vision. That's a concept they use. Like what you can see here, the surgery, the image kind of in the middle here. I'm not sure you see my mouse, but you can see the annotation. That was supposed to be the futuristic or 3D scan objects, or like MRI or CAT scan that you have of the patient, and you superimpose them right on the skin of the patient that on the operating table. Okay, so that's why we have to do that. One of the key reasons is that to help for better planning, minimize the damage to the patients due to the surgery. You know where your optimal place to cut to make the surgery insertion point. Some of those. So the interaction part for this is relatively static, passive. So this one is simply just information that you just allow you to see. Okay. And you're not really touch on it, on activate anything. It's simply just appearing. Okay. So, but it's very useful in guidance, training, visualization in general. Okay, so it's quite a classic one. Some of these are people think about different things in the past, like annotating environments. When the mobile app came up, so they have an app, maybe they put out some information. This is a concept that people thought of at that time, but obviously this is not a concept that really that popular or useful. First of all, is that with the handheld here, you won't see people be able to sustain their hands, and fatigue will come to be issues. And then it's also privacy is a key thing. Okay, so in this case here, it's still, I think, some of the project is still looking into that annotated space. Wikipedia provide you a contextual information. So used to be a company called Wikitoot. Now Wikitoot is moving to other kind of using different techniques. But the idea here is to use 3D geolocation map combining with the localization on the ground to provide person name, identity. It might still be secretly used in the governments, but essentially here, this is what it's look like. For the automobile, this simply could be the GPS on the car, but a 3D GPS running on the windshield that allow you to see the direction in three-dimensional. Okay. So the advantage for this one is it's relatively simple, okay, to use. Okay, so this one actually it has a video. Again, it has an audio, but I wouldn't think it's. So this is a project done as a prototype for AR library will look like. Okay, so don't worry about the don't pay attention to the to the form factor, okay, because the marker here is a passes less, I would say less advanced version, early version of AI technology that use a lot of this fiducial marker. That's what Wuforia is standing for at the moment. As you can see here, he has all the physical marker around him. And that keyboard come up. Rectangle square there are for navigation purpose to guide you where to look for in 3D. So it's just a concept to use to demonstrating. And that's his so-called portable computer. So this is the task is try to find something that's typically harder to find. This concept didn't really quite take off because people nowadays don't go to library, and there's less no real world demands. And it's also the kind of a requirement to have all this tag. Okay. But it's good to demonstrating the key design parameters for consideration for design AI navigation. And you can see here, there's no, for the navigation part, there's no active interaction. You simply just pop up. Yeah, it does require anchors, and the whole system need to know where they are. Each marker representing specific location on the shelf. So that means that even with these primitive AR tracking technology, I mean, with the proper design, they can still manage the whole wide area tracking, which is very difficult at that time. So hopefully you get the idea. Okay, but however, the disadvantage for this one is limited interaction. You can't really do much except you use this as something that you use to augment your knowledge. Okay. So you don't have much of an altering component to it. Oh, okay. So the second mode here is what we call what I call 3D AR interface. So this is what truly interface will look like. So this is a HMD probably 20 years ago. So display 3D physical space. Okay. I am when I was doing my PhD, I was part of the subject, so I was sitting on the far right. Yeah, that was me. Interacting, so both of these subjects are supposed to interact together, grabbing objects. Okay, so grabbing virtual objects in 3D space and giving a task of what to do and things. So this one you really with this display going to have a stereoscopic display, so it's allow you to see things very clearly in 3D space. So as you move your head around, it's not just look around the 2D image. So you now see stereoscopic components of it. And the viewpoint control, so this is more natural. Okay, so hand interactions, of course, all and the headset here are built with the head tracking system, which the tracking system are mounted on the ceiling. At that time, the tracking system is considered kind of the biggest change, and as well as the optics component. Optic is where you render things in your headset. Okay, there was an optic how to generate the wide field optics, and for those of you who played with HoloLens last week, you would know that even the state of the art of display in certain area are very small field of view. However, in VR with Oculus, that's made through about 7 years ago about how to generate optics of 100-degree field of view. So that's to create a complete immersive, relatively quite significant immersive environments. So that's is a good approach. But for this one, it's really about how to get a virtual object display in space and can be freely manipulated. So you have hand controller, you see the hands, you can move around. So the current one is a HoloLens 2. HoloLens 2, we don't have many of them. We don't have them available for checkout because we only got a couple of them. Okay, so, but we do obtain quite a bit of HoloLens 1s. For the interest of this unit, its HoloLens 1 is more than sufficient. Okay. So in this case, you can see here the viewpoint. You're looking from the view of another HoloLens, that looking at a superimposed image and see how she interacted. So the physical space that you're sitting on has a virtual space, the anchor on top of it. So therefore, you can share the not just physical world that you see together, like naturally, and also augmented layer that you share the space, like what you're having seeing now, which is from the HoloLens, another unit HoloLens looking at how she interacts. Okay. So this is pretty much the future of what a collaborative AR would look like. So the advantage of disadvantage for this class is that it's very good. So this image on the right here is from one of the leading lab 20 years ago in Japan that turned that lab into a games. Okay, so the image, the guy wearing the device. Okay, but if you're looking from the other player that wears same thing, whole thing here being tracked. So therefore, what they see is actually the person is wearing a mask. Okay, so wearing a mask and a suit in AR, and the image at the bottom is showing what they actually see. So this is supposed to be alien games. So you're just supposed to see the alien eggs, and then try to kill it before they kill you. And advantage for this one is that user can fully interact with 3D objects anywhere in space, natural familiar interaction. Disadvantage is actually it's difficult to see, just like what you see in Vuforia. Vuforia in somewhat is better than this one. It's actually you still can holding the virtual object. Even right now, you actually put it on your computer screen, but you can easily print them out into a cardboard and stick the Vuforia marker on it, and you can get some sort of small, some partial tactile feedback. Okay, which is a general physical feeling when you're touching an object rather than you just touch thing floating in midair. Okay, however, it does require a headset is one of those. Okay, and you can use the mobile phone with a lot of Vuforia and AR Core. And you need, but you do need a custom input device, something that you can hold, something you can interact. Okay, so this is slowly changing with the ability for people to use the fully hand recognitions, hand gesture recognitions by the advanced headset in this year particularly. So you can see as I show in Oculus before, even though that's not AR, but the same similar technology apply now to the modern HoloLens like HoloLens 2 that we just got 2 months ago. So that one has, you don't need this one. You have a virtual hand reconstructed in front of you. Okay. But one the large challenge is we call it anchoring, anchor space. So that means that if you have multiple players in there, you need to be able to all of them to be inside the same virtual 3D coordinate system. Whereas X, Y, Z, where 0, 0, it need to be the same thing. Otherwise, they wouldn't be able to sync between each of the module. You wouldn't see the virtual character or virtual arm suit, helmet here on image on the top right to be on the same location with the player. If you are tracking systems that really have not perfectly aligned with the other systems. So, and this is what we call world coordinate tracking system. So the whole space belongs to the same. Currently, you don't deal with this issue at all. So right now, all the element that we have here is a single user only. But that's when you go to collaborative component, what I will talk about in a later lecture. About collaborative, that's anchoring becomes the key part to hold them together. That's remaining for the currently remain one of the difficult part. Okay, how to make that, what platform should be used, what is a protocol that we should use for that. Okay, right now you might have played with Pokemon Go many years ago, and currently, recently there be a derivative version of those like a dinosaur game and Harry Potter's those kind of games. So they use the world anchor based on GPS. Okay, so that one relatively straightforward. Okay, so some of those become more popular. Okay, but it still remain a big change. Okay. So this one, the third type, okay, this is augmented surface and tangible interface. Okay, so this is a basic principle is what happens if the surface, you can interact with the surface. Surface can be augmented. So this one require a lot of on them into augmentation, into using projector, okay, and then how would they interact with you? Okay, so there's a physical object used as controller. So this one could be a stylus, could be some sort of physical objects. Okay, so this is designed to be not really portable. It's very hard to make it portable in this case, but it allows you to be more collaborative. Okay. So this one is work done by University of Tokyo as a prototype. Okay. So image is a bit less, not high quality. So you see that projector, okay? So the two people are collaborating in this space. The study is about collaborative space. Okay. So now projector is now recognized computer that's sitting on. Okay, this is a camera view from the top near the projector from the ceiling. So recognize what they are, and you can see multiple contents are moving between multiple space. In this case, one on the laptop. Laptop is one considered one working space, and then table and object is considered another space. All of this, what it require heavily is able to sync where the laptop is, where the screen of laptop is, where the table are. There's also projector they were interacting with. So there's a marker there to allow it generated which page is supposed to go to. So this is trying to transcend some of the physical layer and some of the virtual interactive layers. So it's quite interesting concept. So this is similar to the current IKEA applications. So you generate it, scan it, get the furniture out. But this research take a little bit further, even though this is almost 20 years ago. It's basically not just picking the furniture, but it's also going to generate a virtual viewpoint. Okay, that's a virtual camera there. Has a physical representation of a camera. Now the camera on the ceiling recognizes that what that is, and that's the view from within the 3D environment that it's looking through. So if he move that physical object, you will see the components moving as if it's actually on the physical space. Okay. So for example, the idea here, it be developed for the Microsoft before Surface becomes Surface. This is the original Microsoft Surface table. Okay. We play with this. One of our PhD students finished and working on this 5 years ago. So the projector here become a display, you can interact and you can put a physical object on there and recognize what the physical object's supposed to do, and then you can rotate them around or can interacting using that physical object, because at the bottom of the physical object is actually have a marker that this surface has a capability of a camera capture what they are. So when they rotate it, just like Vuforia, they can tell how this thing is rotating, and then therefore you can build an interaction for it. So this is one of the most, this is one of the things that people use for commercial. Okay. Okay, so this showcase at conference. Okay, you can see the shoe itself doesn't have this layer, but it actually allow you to project different shoe. The cameras are moving freely in 3D space. This is normal, that's regular shoes, but then you want to add different textures. And this concept has been extended to automobile as well. Okay. And you hold iPad in the car showroom, you might see a different color, you might see different features. The idea here is try to come up with the interaction that makes sense for them to actually interact with the physical object, in this case, shoes. Okay. So what makes sense for the shoes? Of course, you not necessarily want to change the shape of the physical shoe, because that's hardly to be able to control it. That's a projector. Yeah, this is the same concept. But one thing you would notice that the surface of this object, to make this work technically, they have to have the objects to have a neutral color and not reflective. It got to be a retro-reflective material, so that for the light will not reflect. It would just, the angle of light will come back to where the light coming in, not reflected to other location. And that's another idea. Remember, most of the AR in the case 1 and case 2 are really about the contents of floating. This one is contents are linking to the physical objects. Okay. So this is another good example. Okay, this one is done by MIT Media Lab. This one is also make use of physical objects. Okay, so this one you can see here, there was inside of that brush has a LED to illuminate the light. You have a camera in the bottom of that. You have touch sensor. So this one is really aimed to generate what we call engaging experience. Okay, camera recognized, and you can paint it. This one does have a fun music, but I guess you don't hear it. So he's captured a video sequence, replay it. So you get the ideas how people, this is a front end of the user, how to get people to engage with them. Okay. So this one just show a different trick, but it's the same underlying same technology. stop this one. So this one has what representation as tangible representation. So that means Bus provide you with basically when you see it, you kind of get the sense because humans has a model understanding of what they're supposed to look like, and these kind of interface allow them to capture that or design so that the humans actually physical recognize that. Okay, and you have physical control. Okay, so that's what blush handling. Intangible representations, and that's what the color and the color is capture. Okay, the texture, the image, and camera inside the brush. Okay, so be able to present. And then the fourth one is the output. So that's what you see on when they're interacting on the screen. Remember this one is the brush is being tracked. So basically every time you touch it, it can send on a physical object, so it's put something out there. Okay, so this is what generating. If you remember those diagram of creating an experience, this is at the top layer of that. Okay, maybe it's worthwhile for me to kind of shift toward that. So this one, the slide I'm talking about. Okay, sorry. You can see here, there was a component, there was a technology, there was a hand, the brush thing, the tool, of course, the software development, interaction, it was design, how to wave the brush, how to interact with the screen. But the first foremost is what the experience will look like. That applications are quite popular from, of course, all ages. It's been used for a museum to discover some of the things. Just imagine you are having a discovering of some archaeological finding, and then but you have to excavate it. So you have to have used this blot to keep moving it, so the object becomes clearer and clearer. But the object is actually being placed from the projector on the top, so they can change it as you interact. Okay. So let me go back quickly. So hopefully you get some sense to that. So the advantage with this one is natural feeling. Okay, so it has ability to people to easily understand. So you don't need to expect them to people will feel more comfortable with these tangible objects if you do designs correctly. Okay. The disadvantage is interaction is limited to the physical dimension of the tangible object itself. This is sort of inherent for the fact that it's actual physical form. So therefore, you cannot turn a brush into something else because it just look like a brush. Okay. So and then the thing is also you can't really until it's actually interact with the object that you design for in that previous example with the screen. You don't really know what digital state, whether it acquired information correctly, things like that. So there's no way to telling by itself, okay, by the brush itself, what it's actually doing at that particular moment. Okay, that's what lead way to the last class, okay, which is representing Vuforia is now representing this class quite well. So this is where you are merging between the tangible component that you are come from previous class and the AR interface from the previous two class. They kind of mixed it. We call them tangible AR interface. So where your AR can display it, you can also touch them. Okay, so that's what is enhanced capability. So this is a project. The first the image of the lady with the samurai characters, that was a project originated from in University of Washington in Seattle. And this is a project we do in in the previous here in at the HIT lab here of early work. This is one of my the first project here at the HIT lab in Australia here, up in Newnham. So this is, you can see the tangible object here, the turntable dial here that keep moving, and the camera can see, and depending on how rotated, it will change in the menu and function, with reflected on the physical map here with the different sensor data. Okay. So this one is actually done using similar concept, okay, but done in, I think it'd be interesting to look at them. This is, it'd be good to actually listen to music for this one actually. But here is that people are just using this and the volume and the pitch of this. So the way you rotate this one is generating a concept of changing the pitch of the music, just like the DJ and they're doing when they're moving the disc. Okay, so that's this interaction directly. So in this case, it's actually going up and down, generate certain thing, tilt them, generate one thing, rotate them, generate one thing. Okay, so this is the application experience itself is really about sound, okay, and collaborative sounds. Because remember, you can have multiple of these people, multiple person play at one time. Okay, idea here. So you're also looking. AR part is what you're looking is augmented content. In this case, is physical frequency and virtual contents. Okay, and this is multiple people collaborative. And you can see the card, the music disc that was designed so that it actually people recognize what they are. Okay, but the technology itself doesn't require that shape, but design that shape so that people can recognize, just like the brush. Again, make it to look like a brush. People will use them like it. So this is seen you don't hear. So the music is changing based on that interact, okay, frequency, tracks, and things like that that allow them to generate a new sound. Okay, so hopefully they give you some idea. Okay. If you're interested, you can look at the paper that lists at the bottom left there. The disadvantage for this one, advantage for this one is seamless interaction with both virtual and physical tools. This one is just like Vuforia is representing now. So that one is spatial interaction with virtual objects. So now you can grab the object. But right now, if you use a webcam and you use the marker on your phone, your marker on your phone becomes interacting. But normally you can actually turn your phone, print out the marker, the physical image target, Vuforia target, to be your physical marker, and to be, let's say, a virtual a box, and you attach the marker or the target on top of it. It becomes a physical component. Okay, so don't try to look beyond what you're actually doing in the tutorial, because we're limited to screen interaction. But that is actually, you can print it out and you can tie it to the physical objects. The disadvantage, of course, the marker is required. Okay, so you need to see this visual markers. Okay, so it require that's just like the virtual library before, augmented library before. It was part of the components that come with it. However, the last point here, if ARCore is using, that means ARCore in the tutorial, I think Ron showed you, I think last week or week before, is that you now can do by, it's more modern, more advanced technology with tracking here. You don't really need a spatial physical marker anymore. However, the problem, not the problem, the trick for ARCore here, it can know itself, it can navigate, it can disorient itself in its space, that it has a surface to recognize by the camera, creating a model. However, it doesn't know where it is every time it turns it on. So that means it doesn't always know the virtual character need to be sitting on that physical marker. Unlike a less advanced version in Vuforia, which is actually whatever they see, they recognize right away what target they're looking at. So therefore, ARCore is actually required for you to actually not only it go with advanced tracking. However, it doesn't know where they are, where it is in space, in absolute term. Okay, so that means that you have to have a file. What the term I repeatedly in this session is called anchor. So you need to find a way to anchor the contents. Okay, anchor the content, anchor the coordinate system that you're tracking using your reference list, ARCore in the tracking. So that become a technical challenge in some way. Okay. So hopefully this is give you enough of what give you some idea of what interaction might be looking like. So hopefully provide you with some guide or some idea of how to build your assignment tool. Okay, so remember, assignment tool, you don't actually have to go fancy. Okay, idea here is that whether you address the design correctly, adequately or not. Okay, so the interaction could be very simple. I mean, could be very simple, but hopefully fit within the context that you're looking for, and then everything else should be okay. Try to pay attention to the design component, as I said before. All right, any questions?